More and more companies globally have to collect more and more data and have to process, to search tons of data, and more applications out there producing tons of data every day. So the modern solutions depend on big data. So it becomes more and more important to be able to, being able to collect and connect data and search data almost in real time. So this new IoT industries really depend on data, and the modern software solutions have to be able to process data mostly in real time. So, and here the question is, are the current data technologies are still suited for solving these problems and being able to deliver such results in memory computing and querying data live. It's really astonishing, so that Amazon, they found out in 2009 in a study that 100 milliseconds of latency cost them 1% in sales. So this is really incredible, which means it really depends, millisecond depends and performance depends. But not only performance, because we as developers, we are interested in convenience and productivity. And this talk is all about this topic, and I'm working on this stuff since more than 15 years now. So my name is Markus Kett. I'm CEO and co-founder of MicroStream. I'm working in the Java environment since more than 15 years, almost 20 years now, and with my teams we have built 2 complete Java IDEs, and here we had lots of challenges in terms of database development. For instance, we built a kind of like Visual Basic for Java, and the goal was to simplify and accelerate database programming with Java. So we built a beautiful GUI builder based on Swing, and it was possible to build great user interfaces within 5 or 10 minutes. It was incredible. But as soon as the users wanted to store data, the horror began, because then they have to use complex frameworks like Hibernate, object relational mapping frameworks, and complex query languages that were not really convenient. And the application finally were super slow. And so we were really in trouble. So we tried to improve this and worked on the JBoss Hibernate tools for Eclipse for more than 10 years now. So we really tried to improve database development with the conventional database or Java stack for database development. Finally, we learned that we can do whatever we want. It's really not possible to solve this problem, because we were not able to solve the core problem. And so we tried to work on something different, and this was what I'm working today on the MicroStream open source project. And this project depends on system prevalence concept. I will talk about this also later. And now this solution is also available on Android. So actually, we are passionate Java developers, but we are also, of course, passionate Android developers. So just a question, who of you develops mobile apps? Okay, and backup applications? Nobody works on backup. Okay, I'm sorry, backend applications, not backup. No, nobody works. Okay, backend applications. Okay. So very often the mobile applications have to work together with backend applications running on server. About the agenda. So first of all, I want to talk a little bit about the challenges in database programming in general. Then I would like to introduce the system prevalence pattern, and then I like to introduce you to the open source, MicroStream open source project. I show some code, and of course we have time for Q&A. So what is actually the core problem in database development in all object-oriented programming languages? So the problem here is we are used to use objects everywhere. So we are used to, everything is an object, and we are used to use objects, of course. So data also are objects. But as soon as we want to store data, then we are used to use relational databases because the relational databases are the standard. The problem here is that databases work fundamentally different from Java objects. So, and it's actually, from technical perspective, not possible to store a complex object graph in a relational database. So we are in trouble. We have some challenges here, and it's called impedance mismatch. So we have several impedance mismatches because the Java object model does not fit to the relational model. So the object model is much more granular than the relational model, for instance. And subtypes are not supported from the relational model, and so on. We have lots of data type mismatches. And this is the reason why we need mapping or data conversion between the application and the database. This technical problem cannot be solved. And there are only solutions around the problem that we are able to use relational databases. Now we can use the modern NoSQL databases, and the question often is, are they better? And I would say they are different, because now they introduce completely new data structure. And all of these databases, they provide their own database-specific data structure or format. And they are all incompatible with the object model. So, which means no matter which database you use, it will be incompatible to your object model from the technical perspective. So this is the reason why we need a layer between the app and the database, so-called object relational mapping, or a data conversion, like JSON conversion, for instance. And we need this data conversion through every single read and write. And this might be a problem, because we need additional computing time. It slows down the app. It requires additional CPU power. And on the server side, in the cloud, it increases the costs. But we have the same problem on mobile devices as well. The problem should be solved with in-memory computing, because it accelerates database applications. And it's because the results are stored in the memory, and memory is much faster. So it's a good idea to use in-memory computing. So, which means we need another layer in our application. We need a cache. But also the complexity will increase more and more, because there's another layer. You need a configuration here, and this is a source of errors. Some people believe it is a good idea to use another layer, because now we can use, for instance, an in-memory data grid on a server, or we can use a distributed cache, or some teams use searching servers to accelerate database queries. Okay, then we have another layer, but all these layers and solutions are also incompatible with our object graph model. And this core problem leads to huge cluster solutions, and the costs are increasing more and more. Then we have on the server side another challenge with microservices and traditional database servers, because here is a rule: each microservice should have its own database. I mean, each microservice that stores data should have its own database, and this is really challenging, especially in the cloud, because sometimes we have in the cloud hundreds or thousands microservices, and all of these services should have its own database. So this is also challenging. How can we solve it? On the server side, we can solve it with system prevalence, and this concept also works great on mobile devices. What is actually system prevalence? The idea is keep your system state in memory and use core features of your language to query your data in memory, so you process your data in memory with core language features, like Java streams, for instance, and then to save data persistently on disk, simply create snapshots. And then everything becomes super simple, because now you only need an app, you keep the system state in memory, and you only have to create some snapshots to store your data persistently on disk. Looks really simple architecture, looks great, but yeah, this is also challenging, and there are numbers of reasons why you won't do that, and it's because snapshots can be too big, even in mobile devices. The snapshot time can take too long. You can lose data between the snapshots. So many reasons why you won't do that. But when the system prevalence concept was introduced around 15 years ago or so, the expectation was memory in the future will be super cheap, so you can keep all the data in memory. We won't have any problems. But unfortunately, it's not true. So we have a list of issues here, and we worked on these issues. And with the MicroStream open source project, we have now eliminated all of these issues. And then system prevalence becomes really a super interesting concept. How does this work? With MicroStream, you have a persistence layer, a Java persistence layer for the JVM and for Android as well, that runs within your app or in your microservice in the same process. And it enables you to store your object graph as it is in memory, mostly subgraphs, persistently on disk, and vice versa. It allows you to load any single subgraph and restore it in memory when it's needed. So here we have the architecture again. We have the app layer, we have the objects in memory, and MicroStream as an API, open source API. We can download via Maven, and the JVM or the Android runtime. And now we are able to read the data from the memory. And if there are changes on your object graph, so let's say customer object changes, then you can just call a store method and your object becomes serialized into the file storage. And only the changes are serialized and stored persistently into your file storage. So just the data, the delta is stored. And you can choose your data storage target. So you can store it in plain files. You can store it also in blob stores like AWS S3. And you also can store it into NoSQL databases and even in relational databases, because it stores binary data. And with this concept now, data conversion and mappings are completely eliminated. There are no more mappings, and you don't have to adapt your object model to a database-specific data model. Of course, it works great on Android, and here we have pretty much the same architecture. You have your app, you have your objects in memory, and you decide how many data you want to load into the memory. You have full control about this, and you only need MicroStream as a tiny dependency, and then you decide which object references are stored persistently on your device, or not only on the mobile device. I mentioned already, you can also store it in a blob storage in the cloud, or in a local database, in a cloud database. Here are the supported storage targets. All of these storage targets are supported by the core open source framework. The engine runs on Android, on the JVM as well, in containers, microservices. The only requirement is Java version 8. Of course, it works also with JVM languages like Kotlin. So MicroStream is a persistence layer, and the core of it, it's a serialization written from scratch. So it does not depend on the Java serialization, because Java serialization is around 10 times slower, sorry. It's slower, and it's limited in terms of you have to implement serializable and so on. With MicroStream, this is not mandatory, and it also has a layer for legacy type mapping, which is a kind of like class version handling. So it handles your changes on your classes automatically. It comes with a garbage collector for the file base, file system abstraction, so you can choose your storage target. Database connectors, I mentioned it already, a REST interface that allows you access to your storage data, and a storage browser, and so on. Backup functions and data converters, and a cluster solution for the server side. But of course, we are at the Android conference, which means mobile devices are much more interesting for us. So here again, you can download it via Maven, and the project is not a prototype or so. We started the project almost 10 years ago, and 4 years ago we launched MicroStream as a product. Last year we have open sourced it, and 1 month later the Oracle guys have integrated into Helidon, which is a microservice framework that is driven by Oracle, and last month MicroStream was integrated into Micronaut, which is always also a microservice framework. We have great people from the community behind this project, and I mentioned it already, it's part of Helidon and part of Micronaut. We are also contributor to the Micronaut project and sponsor of the Micronaut project. And now the question is, how does MicroStream work? It's really simple to use and really convenient. Just download it via Maven. You just create an instance, MicroStream instance of your database. There is a root object. It's similar to a tree control, and then you can add your objects, and you can build your object model completely freely. You just need POJOs. You can see there is nothing else. There are no annotations. There are no interfaces to implement, and no superclasses and so on. Really, just POJOs. Build your object model freely, which means there is no need to adapt your classes to a database structure or a model, you can use almost all types. You can add your custom types if you like. You can use and store objects of third-party libraries. You can use circular references in your object graph. You can use inheritance, whatever you like, everything that is supported by the programming language. So build your object model that it fits to your use case. So here we have a small demo. So we create a MicroStream instance, and the MicroStream instance creates a file storage. This is your starting point. Then you can persist objects by just call one store method. So create an object and store it by calling the store method. That's it. And then the changes in your object graph are stored automatically. So here I add an object, I store it, and then MicroStream stores a binary data to your file storage. And it's stored appended. So each store method call creates a new binary in your storage. So here I add some further objects, and you can see my storage will grow. And this is how MicroStream actually works. So if you change an object, it's pretty much the same. So I change an object reference, I store the object reference again, and then the new object is it's stored as a new object appended to the file storage. When you start your app initially, then MicroStream loads all object IDs into the memory, but only the object IDs, no data are loaded initially. So then you have your complete object graph as a structure in memory. All objects are connected via the object ID. And to load data, you just have to call a get method. Get customer, for instance, then MicroStream loads the object reference automatically and merges automatically into your object graph. So you don't have to deal with object copies. This is really convenient, so just call get and set methods. That's it, fully object-oriented, no more dealing with classic selects. Of course, you have full control of which data should be loaded initially or lazy. So it's recommended to use lazy loading in any case. So, and it's simple to use. It's just a wrapper class, and then your object will be loaded on demand only. So we have our object graph in memory, only the object IDs. I load an object lazy, and then it stays in the memory. So and I can continue and load further object references with lazy loading into the memory. And then you can search on your object graph with Streams API. And this is really super fast. And you have full control of these lazy references. So if you have concerns about memory size, then you can clear your lazy references anytime. So you have full control. You can define timeouts to reduce the RAM size. Yeah, as I mentioned, querying the object graph, you can use streams, Java streams or GraphQL. So this is core Java. And searching object graphs in memory is really super fast. It's, so you can try this out. It's mostly only some microseconds. And in comparison to a database, we talk about mostly about milliseconds. So, which means searching object graph with streams is up to 1,000 times faster than traditional SQL query. If your class is changed, then I mentioned it already, then we provide a so-called legacy type mapping, and it solves the changes automatically behind the scenes. So there are also some rules and challenges with MicroStream. It's a paradigm shift in database programming because here on the left side we can see the traditional database server paradigm where we have our app, and then we have a database server runs on a remote machine, and most developers think in this traditional database server paradigm. As an app developer, this database mostly runs also as an in-memory database inside your mobile app. And with MicroStream, we have a paradigm shift in terms of now the data in memory are our database. So this is our in-memory database, and there is no more remote server or database we have to query. There are only storage data that are stored in plain files, and we do not have to query this storage data. So we query the object graph in memory. This is the paradigm shift. And this is sometimes a little bit challenging for developers because we are so familiar with the relational model. But just think as a Java developer or a Kotlin developer, think object-oriented, and then it becomes really easy. Then many developers have concerns about the database size. So this slide is built for server-side applications, but it's the same with mobile apps. So if you have enough storage, then of course, and you have a small database, you can load the entire database into the memory. It depends on whether startup time is important for you or not. So it's your decision. If your database size is very huge and you have a small size of memory, then it also works perfectly because you have the lazy loading feature. So this slide might not that important for you because so I asked the audience who is a backend developer, but nobody works on backend solutions. So MicroStream can be used on the server side as well, and also a cluster solution is available. It's pretty much the same library, so you don't have to write different code. It's really the same code, and you also can build huge cluster applications with MicroStream. Now, what are the benefits? I would say the benefits are higher productivity. So it's super easy to use. It's so easy to store data. You can skip all this boilerplate code you have to write when you use a traditional database. You have great performance, and this is not because of MicroStream. The performance comes from the Java runtime or from Android runtime, and from streams, which is a core language feature, and this is not MicroStream hocus pocus, and it minimizes the costs of development, and on the server side, the cost of infrastructure as well. Are there any questions so far? No questions. Okay. I'd like to talk about this feature of, I mentioned this legacy type mapping. This is most challenging for many developers. What happens if my classes change? This is not a problem for MicroStream. It's that this is solved. So if you, let's say you start the app for the first time and then you store a customer object, then you have the first version of your object in a storage. Then you want to change your class, you add some fields, you remove some fields, or you rename fields, or you change some primitive types. Then you start the app again, you load the object, then MicroStream compares the loaded object to your new version of your class, and it recognizes there are differences, and these differences can be managed automatically through runtime by MicroStream. And if there are cases that cannot be solved automatically, like you add an object, for instance, or you change objects, then you can define a custom type handler. And then you have to store your object again, and then you have the second version in your storage. Now we have two versions of the same object in the storage, and now you can define if you want to keep these two versions. Then we have a kind of like class versioning, or you can decide to remove the legacy object from the storage, and to do this we have a kind of like garbage collector for the file storage, and you can configure that how the garbage collector should remove the legacy objects from your storage to keep your storage clean. So this is really simple in our slides here, of course. So we have here some legacy red legacy objects, and the garbage collector will remove the legacy object from the file storage and keep the storage clean. In terms of memory management, so the memory is fully managed by the runtime, by your Android runtime or JVM. You have full control of your lazy references. You can clear your lazy references anytime. Can define timeouts and so on. If you work on a server side, you can use JVMs that are faster and less memory hungry, like the Open J9 JVM or the Azul JVM. So the entire framework is open source. So it's under EPL, Eclipse Public License, which means you can use it. You can use it for commercial purpose also. You don't have to pay any license fees in no case. And the only requirement of the EPL is if you improve the framework itself, then you have to publish the improvements under EPL as well. These are the only requirements of the EPL. But the custom code you write, so if you build a proprietary app, you of course do not have to open source it. So you can use it. And if there's anything missing in MicroStream, you can use any Java library that's available in the Java ecosystem. You can use any solution that's provided by third-party vendors, for instance, to combine it with your application or mobile app. And MicroStream is only for storing and loading the object graph, so it's developed on separation of concerns. It's not another database system, it's really only a solution for highly efficient storing and loading your objects. If you like to learn more about MicroStream, you can check it out on microstream.1. The code is available on GitHub, of course, and we have really a great documentation. And it's written for server-side applications, but it's really pretty much the same code when you build a mobile app. So I'm pretty sure that you will be understand it very quickly and will be able to use it very quickly. We also have videos on YouTube, and now especially for the DroidCon conference, we provide online training courses for free by using this booking code. The trainings are provided by Java Pro, which is a German Java magazine, and MicroStream is the sponsor. Yeah, can use this booking code, can share it with your friends and colleagues, and pick any course and book it for free. And with this course, you can also book additional courses about Quarkus, Micronaut, and other microservice frameworks. Questions so far? Yes, please. Yeah. So the question was about security. Is there any solution provided by MicroStream? And for this great question, I'll give you a t-shirt. Not bad. So all good questions get the t-shirt, of course. And if anybody has a good answer, gets also a t-shirt. Actually, the answer is no. Currently, no, not yet. And because MicroStream was initially built for the server, for backend applications, and to replace Hibernate 10 years ago. And on the server side, mostly the infrastructure cares for security, so we do not touch it, or should not touch it. It's different on Android mobile devices. This is the reason why we're currently working on this, and hopefully in September or so, when the next version is planned, we are able to provide some security features you can use. So, and currently you can use everything that is available, any library that is available, you can use for that. Another question, yes, please. Can you repeat it, please? In memory? Okay. It's really hard to understand this for me. You mean in comparison to SQLite when I use it as an in-memory database? Okay. I think the biggest differences are that MicroStream does not provide a data structure like a database does. So there is no database-specific data structure, no database-specific types. All of these limitations of databases are gone with MicroStream, because now you can use everything that's provided by Java or you're using Kotlin. So all these types you can use collections, and all these database vendors, they talk about the perfect data structure. Actually, what is the perfect data structure? We talk about domain-driven design, and which means, hey, for this or that domain, you can use this or that data structure that fits great. So now they are building the multi-model databases that provide all data structure in one, but actually in Java or on Android, we have already the perfect data structure. It's an object graph. We have it already, so we can use single objects, we can use lists, we can use collections, maps, everything we like, we can use it. This is the perfect data structure actually, and you can use all of these types and you can persist it with just calling one store method, and that's it. And this is the main difference, I would say. And it does not store your data in tables anymore. So it just uses a binary format, and with this binary format, it is possible to store everything. So we can deal with circular references, any complexity, any depth of the object graph can be handled, and this is the powerful thing here. No more mapping, no more data conversion, yeah, just storing the object as they are used in the memory. Yes, please? Yeah, the question was what happens if the app crashes or something else happens, right? With MicroStream itself has a kind of like journal, so transaction journal. So each store is an atomic operation, all or nothing operation, and it's kind of like transaction safe. So in comparison to a relational database, either your store method is successful, then the binary data are added to your file storage, and we get an internal commit. Or it fails, then you get an exception. There is also no rollback because if it's successful, then okay, then we get the commit. If it's not successful, then the legacy object or the fragment will be removed by the garbage collector. So this is very, very easy. And of course, teacher, for that question. Can, if the size does not fit, then you can change it on our booth, of course.